Let me bring you up to speed with the absolute latest on this cosmic visitor. Comet 3I Atlas, officially designated C 2025 N1, has just made its closest approach to Mars on October 3, 2025, passing within a mere 18 million miles of the red planet. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter captured unprecedented observations of this interstellar wanderer. As we speak, it's hurtling toward its perihelion, its closest approach to our Sun, scheduled for October 29th to 30th, 2025, where it will pass at a distance of 203 million kilometers. Right between the orbits of Earth and Mars, the James Webb Space Telescope has just released data showing this comet has the most extreme carbon dioxide to water ratio ever recorded, 8:1, and scientists are now suggesting this visitor could be a 10 billion-year-old relic from the ancient Milky Way. NASA's Psyche spacecraft and multiple Mars orbiters are currently tracking it, while astronomers worldwide are racing against time to unlock its secrets before it disappears forever into interstellar space. What if I told you that we've just received physical proof that other solar systems exist? Not theoretical proof, not mathematical models, but an actual object that has traveled across the unimaginable vastness of interstellar space to visit us. Ladies and gentlemen, meet Comet 3I Atlas, the cosmic equivalent of finding a message in a bottle. Except this bottle has been floating through the cosmic ocean for potentially 10 billion years. Yes, you heard that right, minus 10 billion years. That's more than twice the age of our entire solar system now. Before you think this is just another space documentary that's going to bore you with technical jargon, let me stop you right there. What we're about to explore together is nothing short of mind-blowing. This comet isn't just passing through, it's rewriting textbooks, challenging our assumptions, and opening doors to questions we didn't even know we should be asking. And the craziest part, scientists are scrambling right now, at this very moment, to study it before it disappears forever into the cosmic void. Think about this. Every comet you've ever heard of, from Halley's Comet to Hale-Bopp, they're all locals. They're part of our solar system family, orbiting our Sun like cosmic housemates. But 3I Atlas, this visitor knocked on our door from somewhere so far away that light itself would take thousands, maybe millions of years to make the journey. And unlike light, which travels in straight lines, this comet has been bouncing around the galaxy like a cosmic pinball for eons. The discovery story alone is worth its weight in cosmic gold. The Atlas Survey Telescope in Chile, which, by the way, stands for Asteroid Terrestrial Limpact Last Alert System, because yes, its main job is to spot things that might hit us, was doing its regular sweep of the sky when it spotted something odd. The object was still 4.5 astronomical units from the Sun, roughly the distance of Jupiter's orbit, but something about it just didn't add up. The way it was moving, the speed it was traveling, everything screamed this doesn't belong here. Can you imagine being the astronomer who first realized what they were looking at? Picture yourself sitting in front of a computer screen, probably sipping your 10th cup of coffee for the night, when suddenly the data starts telling you a story that seems impossible. The calculations show an object moving at 130,000 miles per hour. Let me put that in perspective for you. If you could travel that fast, you could circle the entire Earth in about 11 minutes. You could get to the moon in less than 2 hours. But here's where it gets really interesting. That speed is way too fast for anything that belongs to our solar system. You see, every object in our solar system is like a dancer following the sun's gravitational music. They speed up when they get close, slow down when they move away, but they're always bound to that cosmic dance floor. But 3I Atlas, it's moving like someone who crashed the party, sprinted across the dance floor, and is heading straight for the exit door. Its trajectory is what we call hyperbolic. Imagine throwing a ball so hard that it never comes back down. That's what we're seeing here, except the ball is a comet, and it's been flying through space since before our sun was even born. The numbers are absolutely staggering. The comet's orbital eccentricity, basically a measure of how stretched out its path is, comes in at 6.14. Now, I know that might not mean much to you, but consider this. A perfect circle has an eccentricity of 0. Earth's orbit has an eccentricity of 0.02, making it nearly circular. Even the most eccentric comet from our own solar system barely breaks 1.0. But 3I Atlas, it's off the charts at 6.14. That's like comparing a gentle wave in a swimming pool to a tsunami. It's not even in the same category. But wait, it gets even more fascinating. When scientists traced its path backward, and yes, they can do that with incredible precision using computer models, they found that this cosmic wanderer entered our solar system from the direction of Sagittarius, near our galaxy's center. Now, here's a fun thought experiment for you. What if this comet has been to other star systems before ours? What if it's been collecting chemical signatures from multiple stellar neighborhoods over billions of years? We could be looking at a cosmic time capsule that's older than Earth itself. Speaking of age, let me blow your mind with something that scientists recently discovered. Using sophisticated modeling techniques, researchers have been tracking this comet's journey not just through our solar system, but through the entire galaxy. They've rewound the cosmic clock for 0.27 million years, and you know what they found? In all that time, traveling through regions populated with stars, this comet passed within gravitational influence of 62 different stars, and not a single one of them significantly altered its path. Do you understand what that means? This thing has been on a practically straight trajectory for millions of years, which suggests it came from somewhere incredibly far away, possibly from the boundary between our galaxy's oldest and youngest stellar populations. Now, you might be wondering, okay, so it's fast and it's from far away, but how do we actually know it's from another solar system? Couldn't it just be a really weird comet from the outer edges of our own system? Great question. And this is where the detective work gets really interesting. You see, comets are like cosmic fingerprints. The chemicals they're made of tell us about the environment where they formed. And 3I Atlas, its chemical fingerprint is unlike anything we've ever seen from a local comet. The James Webb Space Telescope, you know. That incredible machine that's been sending us those mind-blowing images of distant galaxies. Well, it turned its powerful eye on our interstellar visitor. And what it found has scientists practically jumping out of their chairs with excitement. This comet is loaded with carbon dioxide, way more than any comet from our solar system. The ratio of carbon dioxide to water ice is about 8:1. To put that in perspective, imagine making a cocktail where you're supposed to use 1 part mixer to 1 part alcohol, but instead you use 8 parts alcohol. That's how extreme this ratio is compared to what we normally see. But here's where it gets really weird. And I mean weird even by space standards. The comet has almost no carbon monoxide, which is strange because CO and CO2 usually go hand in hand in space. It's like finding a peanut butter and jelly sandwich with no peanut butter. This unusual composition suggests that wherever this comet formed, the conditions were dramatically different from our own solar system's birth environment. And speaking of weird, let me tell you about something that has scientists scratching their heads. This comet started forming its coma. That's the fuzzy cloud of gas and dust around the nucleus, while it was still way out beyond Jupiter's orbit. Most of our local comets don't wake up until they're much closer to the sun. It's like having a house guest who starts making breakfast at 3 a.m. The early activity is probably due to all that carbon dioxide ice, which sublimates, turns directly from solid to gas at much lower temperatures than water ice. Are you still with me? Because here comes the part that's going to make you question everything you thought you knew about the universe. Ready for this? Asterisk when scientists detected nickel and iron in the comet's gaseous plume. They found the ratios were completely off the charts compared to anything we've seen before. We're talking about extreme abundance ratios that don't match either our solar system's comets or even the previous interstellar visitor, Comet Borisov. It's like each interstellar object is telling us a unique story about its home system, and each story is wildly different from the others. Now, I need you to really grasp the significance of what we're discussing here. This isn't just about a space rock flying by. This is physical evidence, actual, tangible, you could theoretically touch it evidence that other stars have planetary systems. For decades, we've suspected this. We've detected exoplanets through wobbles in starlight and shadows passing in front of distant stars. But this is like the difference between seeing footprints in the snow and actually meeting the person who made them. Let me paint you a picture of this comet's incredible journey. Imagine, if you will, a time before our sun existed. The Milky Way was younger, wilder, with different chemical compositions in its stellar nurseries. Somewhere in this ancient galaxy, a star was born, and around it, a disk of gas and dust began forming planets. In the cold outer reaches of this disk, our comet began to form, accumulating ice and dust, grain by grain. This process took millions of years, creating a dirty snowball that would eventually become our interstellar messenger. Then something happened. Maybe a close encounter with a giant planet in that system, or perhaps the gravitational disruption from a passing star. Whatever it was, our comet got ejected from its home system and began its epic journey through interstellar space. For billions of years, and I want you to really think about this timescale, this comet has been sailing through the darkness between stars. While it was traveling, our own sun was born. Earth formed. Life emerged from primordial soup. Dinosaurs rose and fell. Humans evolved, built civilizations, and eventually developed the technology to detect this ancient wanderer. And now, in 2025, our paths have crossed. Out of all the possible trajectories through our vast galaxy, out of all the possible moments in time, this comet has arrived during the tiny sliver of human history when we're advanced enough to recognize it for what it is. If that doesn't give you goosebumps, I don't know what will. But here's the thing that really keeps me up at night thinking about this. And maybe it'll keep you up too after you hear this. We've only discovered 3 interstellar objects so far. The first was Oumuamua in 2017, which was weird enough that some scientists seriously considered whether it might be artificial. The second was Comet Borisov in 2019, which looked more like our regular comets, but still had its quirks. And now we have 3I Atlas, which is throwing us another curveball with its bizarre chemistry. If we've found 3 in less than a decade, how many of these cosmic wanderers are passing through our solar system undetected? Here's a mind-bending thought. Some scientists estimate that at any given moment, there could be thousands of interstellar objects passing through our solar system. We just don't see them because they're too small, too dark, or we're simply not looking in the right place at the right time. It's like trying to spot a specific grain of sand on a beach at night with a flashlight. The fact that we've found 3 is actually remarkable now. You might be thinking, okay, this is all very interesting, but what does it actually mean for us? Well, buckle up, because the implications are staggering. First off, these interstellar visitors are proof positive that planetary formation is not unique to our solar system. If comets can be ejected from other systems and reach us, it means those systems have the same kinds of processes that created our own cosmic neighborhood. We're not special. We're not unique. We're part of a vast cosmic community of planetary systems, but it goes deeper than that. Each interstellar object carries information about its home system's chemistry. It's like having soil samples from alien worlds delivered right to our doorstep. The unusual composition of 3I Atlas tells us that some planetary systems formed in environments with very different chemical mixtures than our own. This has huge implications for the search for life. If chemistry varies this much from system to system, then the potential for different forms of life may be based on completely different chemistry than Earth. Life becomes much more plausible. And here's something that'll really cook your noodle. What if some of Earth's water or organic molecules originally came from interstellar comets? I know, it sounds like science fiction, but hear me out. Over billions of years, countless interstellar objects must have passed through our solar system. Some of them, especially in the early chaotic days of planetary formation, could have impacted Earth or other planets. Could these cosmic visitors have delivered ingredients crucial for life? It's not impossible. And 3I Atlas is showing us just how much material gets exchanged between star systems. The observation campaign for this comet reads like a who's who of space exploration technology. We've got the Hubble Space Telescope scheduled to perform ultraviolet spectroscopy in November 2025. The James Webb Space Telescope is making multiple observations to study its composition in unprecedented detail. The Very Large Telescope in Chile is tracking its movement. Even our Mars orbiters got in on the action when the comet passed within 18 million miles of the red planet in October 2025. Can you imagine being one of the scientists working on this? You're literally racing against time. Every day, every hour that passes, the comet is speeding away from us at 130,000 miles per hour. Once it's gone forever. We'll never see this particular object again. The pressure to gather as much data as possible must be intense. It's like trying to read an entire encyclopedia while someone is slowly pulling it away from you. And you know that once it's gone, that knowledge is lost forever. But wait. There's more, and this is where things get really exciting. The comet's closest approach to Earth happens on December 19th, 2025. Now, before you start worrying, let me assure you it'll still be 170 million miles away. That's almost twice the distance from Earth to the Sun. We're perfectly safe. But here's the cool part. At that distance, with a decent telescope, amateur astronomers might actually be able to spot it. Imagine being able to see an object from another solar system with your own eyes, or at least through your own telescope. How incredible is that? And the story doesn't end when the comet leaves our vicinity. The European Space Agency's JUICE mission, that's the Jupiter Icy Moons Explorer, will monitor the comet when it passes near Jupiter in March 2026. Every observation, every spectrum captured, every bit of data collected adds another piece to this cosmic puzzle. You know what's funny? Well, maybe not funny, but certainly ironic. We spend billions of dollars sending spacecraft to other planets and moons in our solar system to study them up close. And here comes 3I Atlas, delivering itself to us from another star system, completely free of charge. No mission planning needed, no decades-long journey to wait through. It's like the universe is giving us a free sample of what's out there. But here's a thought that might mess with your head a little bit. What if Earth has its own interstellar comets wandering the galaxy right now? During the early formation of our solar system, countless comets and asteroids were ejected into interstellar space. They're out there somewhere, carrying chemical signatures of our solar system to distant stars. Maybe, billions of years from now, one of our comets will pass through an alien solar system. And if there's anyone there to observe it, they'll wonder about its strange composition and unusual characteristics. We're not just receiving cosmic messages, we're sending them to dot the discovery of 3I. Atlas has also reignited debates about something called panspermia, the idea that life could spread throughout the galaxy via comets and asteroids. Now, I'm not saying this comet has alien microbes on it. That would be a bit much even for this wild story. But the fact that objects can travel between star systems means that, in principle, life could hitch a ride. If a major impact ejected rocks from Earth into space, and if some of those rocks eventually escaped our solar system, and if any microbes on those rocks could survive the journey, well, you see where this is going. It's a lot of ifs, but 3I Atlas proves that at least the delivery mechanism exists. Let me share something that really puts this discovery in perspective. When Galileo first pointed his telescope at Jupiter and saw its moons, it revolutionized our understanding of the cosmos. It proved that not everything orbited Earth when we first detected exoplanets in the 1990s. It confirmed what we suspected. Other stars have planets. But 3I Atlas? This is different. This is physical material from another planetary system that we can actually study. It's like the difference between knowing your neighbor exists and having them hand you a piece of their homemade pie. The technical data on this comet is absolutely fascinating, and I promise I'll try not to geek out too much. But some of these numbers are just incredible. The comet's nucleus, that's the solid, icy core, is estimated to be less than 1 kilometer in diameter. That's smaller than many mountains on Earth. Yet this tiny object has survived a journey of potentially billions of years, through the harsh environment of interstellar space, where temperatures hover just a few degrees above. Absolute zero and cosmic rays bombard everything in their path. Think about the forces this comet has endured. In interstellar space, there's no protective heliosphere like the one our sun provides. It's been exposed to the raw, unfiltered radiation of the galaxy. It's passed through regions of different densities, possibly even through the shock waves from distant supernova. And yet, it survived intact enough to still be outgassing and forming a tail as it passes through our solar system. That's like finding a perfectly preserved letter that's been floating in the ocean for 1,000 years. The fact that we can detect specific molecules in its coma is mind-blowing when you really think about it. Scientists have identified water vapor, carbon dioxide, carbon monoxide, carbonyl sulfide, and even cyanide gas. Each of these molecules tells a story about where and how this comet formed. The abundance of CO2 suggests formation in a colder environment than our own comets experienced. The presence of certain complex molecules hints at chemical processes that might be rare in our solar system but common elsewhere. And here's something that'll make you appreciate how far we've come technologically. We're able to detect and analyze nickel and iron atoms in the comet's vapor trail. These metals are being released as the comet's surface heats up, and we can detect them from hundreds of millions of miles away. Our ancestors would have called this magic. Even scientists from just 50 years ago would be amazed at our current capabilities. Now, let's talk about what happens next, because this is where you come in. Yes, you, listening to this right now. The study of interstellar objects is still in its infancy. We've only known they existed for less than a decade. Every observation, every analysis, every theory about these objects is contributing to a completely new field of astronomy. And the public interest in these discoveries drives funding for better detection systems and more powerful telescopes. The more people who understand and appreciate the significance of discoveries like 3I, Atlas, the more support there is for space science. And we need that support, because here's the thing, we're probably missing most of the interstellar objects that pass through our solar system. They're too small, too dark, or moving through regions we're not monitoring. Imagine what we could learn if we could detect and study dozens or hundreds of these cosmic visitors. There are already proposals for missions specifically designed to intercept and study interstellar objects. Some scientists have suggested parking a spacecraft at a gravitational balance point in the solar system, ready to chase down any interstellar visitor we detect. Others have proposed networks of telescopes specifically designed to spot these objects earlier, giving us more time to study them. But these missions need funding, and funding comes from public support. Here's what really gets me excited about all this. We're living in the first era of human history where we can actually detect and study objects from other star systems. Our grandparents could only dream about this. Our grandchildren will probably take it for granted. But we're the generation witnessing the dawn of interstellar astronomy. How cool is that? And it's not just about the science, though the science is incredible. It's about what this means for humanity's place in the universe. Every interstellar object we discover is a reminder that we're part of a vast, interconnected galaxy. The atoms in these comets were forged in the hearts of dying stars, just like the atoms in our bodies. We're all made of star stuff, as Carl Sagan famously said. But these interstellar visitors really drive that point home. The story of 3I, Atlas, also highlights how international cooperation makes these discoveries possible. The comet was discovered by a NASA-funded telescope in Chile. It's being observed by European, American, Canadian, and Japanese telescopes and spacecraft. Scientists from dozens of countries are analyzing the data. When it comes to understanding our place in the universe, national borders become meaningless. We're all in this together, united by curiosity and wonder. You know what's particularly amazing? We're able to study this comet using the entire electromagnetic spectrum. Radio telescopes are tracking its position and velocity. Infrared telescopes are analyzing its heat signature and composition. Optical telescopes are capturing images of its coma and tail. Ultraviolet observations are revealing information about its gas emissions. Each wavelength tells us something different, and together they paint a complete picture of this interstellar wanderer as I'm sharing all this with you. 3. iAtlas is continuing its journey through our solar system. Right now, as you're listening to these words, it's hurtling through space at unimaginable speeds. By the time you finish listening to this, it will be millions of miles farther away. It's a reminder of how dynamic and ever-changing our universe is. Nothing stays still. Everything is in motion. And occasionally, if we're lucky and paying attention, we get to witness something truly extraordinary. But here's the question that keeps me up at night, and maybe it'll keep you thinking too. If we've discovered 3 interstellar objects in just 8 years, what will we discover in the next 8 years, or the next 80? As our detection technology improves, we're going to find more of these cosmic visitors. Each one will tell us something new about the galaxy we inhabit. Each one will be a piece of the puzzle in understanding how common or rare our solar system really is. Some scientists think we might eventually discover interstellar objects that are definitively from specific nearby star systems. Imagine being able to say, this comet came from Proxima Centauri, or this asteroid was ejected from the Sirius system. We could build a map of our stellar neighborhood based on the objects that visit us. It would be like reconstructing a city's layout based on the letters that get delivered to your mailbox. The discovery of 3I Atlas has also raised some fascinating questions about the early solar system. If interstellar objects are passing through regularly, they must have been doing so for billions of years. During the period when Earth was forming, when it was being bombarded by asteroids and comets, some of those impactors must have been interstellar. Could some of Earth's water have come from interstellar comets? Could some of the organic molecules that led to life have been delivered from another star system? We don't know yet, but 3I Atlas is showing us that these aren't crazy questions anymore. They're legitimate scientific inquiries. And think about this, if our theories are correct, and this comet is 7 to 10 billion years old, it's older than our sun, older than Earth, older than any rock you've ever touched or mountain you've ever seen. When this comet formed, the universe was a different place. Many of the stars we see in our night sky didn't exist yet. The Milky Way itself was younger and smaller. This comet has witnessed cosmic history on a scale we can barely comprehend. That the speed at which 3I Atlas is traveling also tells us something profound about the galaxy. At 130,000 miles per hour, it would still take this comet over 20,000 years to reach the nearest star to our sun. The distances between stars are so vast that even at these incredible speeds, interstellar travel takes eons. It really puts into perspective the challenges of interstellar exploration for humanity. If we ever want to visit other star systems, we're going to need to think on timescales that dwarf all of human history. But here's an optimistic thought. If chunks of rock and ice can make the journey between stars, carrying information about their home systems, then maybe one day we can too. Maybe not in our lifetimes, maybe not for thousands of years, but the fact that interstellar travel is possible even for a simple comet means it's not impossible for us. 3. iAtlas is proof that the stars aren't completely out of reach. As we wrap up this incredible journey through the story of 3I Atlas, I want you to remember this. We're living in an extraordinary time. We're the first generation of humans who can definitively say we have physical evidence of other planetary systems. Not speculation, not theory, but actual material from another star's planetary system passing through our own. That's profound. That's historic. That's absolutely mind-blowing. the next time you look up at the night sky, remember that it's not just a static display of distant lights. It's a dynamic, ever-changing environment where objects from distant star systems are constantly passing through. Most of them we'll never see, but occasionally, like with 3I Atlas, we get lucky. We get to witness and study a genuine piece of another solar system, and who knows, maybe one day, perhaps sooner than we think, we'll detect an interstellar object early enough to send a spacecraft to intercept it. Imagine being able to collect samples from a comet that formed around another star. The scientific value would be incalculable. It would be like having a piece of an alien world delivered right to us. This discovery reminds us that we're all part of something much bigger than ourselves. Every star you see might have planets. Those planets might have comets. And occasionally, very occasionally, one of those comets might visit us, bringing with it secrets from across the galaxy. We're not isolated. We're not alone. We're part of a vast cosmic community, connected by these interstellar messengers. So here's what I want you to do. Share this story. Tell your friends, your family, your co-workers about 3I Atlas. Not because I'm asking you to, but because this is genuinely one of the most remarkable discoveries in astronomy. We're witnessing history in the making, and the more people who understand and appreciate these discoveries, the more support there will be for future research. If you found this journey through the cosmos as mind-blowing as I did, make sure to subscribe for more incredible stories from the frontier of science. Hit that notification bell so you don't miss the next time we explore the wonders of our universe. And please, share this with someone who needs a reminder of how absolutely incredible our universe is. Because discoveries like 3I Atlas don't come along every day. And when they do, they deserve to be celebrated. Remember, every time you look up at the stars, you're looking at a galaxy full of planetary systems, each with their own comets and asteroids, some of which might one day visit us, just like 3I Atlas is doing right now. We're all connected by these cosmic wanderers, these ancient messengers that travel between the stars. And that, my friends, is perhaps the most beautiful truth that 3I Atlas has revealed. We're all part of one incredible, interconnected cosmos. Until next time, keep looking up, keep asking questions, and remember, the universe is far more amazing than we ever imagined, and we're just getting started in our exploration of it. Thanks for joining me on this incredible journey through space and time. This has been the remarkable story of Comet 3I Atlas, absolute proof that we're not alone in having a planetary system, and a reminder that the cosmos still has countless surprises waiting for us to discover.